Hi. So when Nabil said he wanted to do talks that were like really deep technical stuff, I said I had something I was working on, and thank you for inviting me to talk about it. So I just want to take a quick poll. How many of you are developers here? Cool. And it's almost everyone. And how many of you work with GraphQL? Cool. So let me just give you some background about my life experiences, and kind of, because this piece is a little bit of an opinion piece too. So it's more like, why have I developed that opinion over the years, and why, what right do I have to talk about some of these things? So I worked in building APIs of one sort or the other my whole life. So after college I founded a couple startups, and they kind of got me to LinkedIn in 2010, and I ended up working on a bunch of stuff there, but mostly the ad serving infrastructure. So this is we got to serve billions of ad impressions at scale, and do all kinds of crazy stuff to get that ad out to you, and so it was very interesting work. I also was part of the team that moved LinkedIn from a more traditional JSP kind of render pages on the server world to a single page app, in which case LinkedIn's backend was just an API serving thing, and then we built this. We chose Ember for several reasons. We can get into that some other day. And we ended up, LinkedIn is now like this rich Ember app. Obviously, having worked startups where I built like monoliths and used technologies like PHP or or Rails, and at big companies like LinkedIn working on Go or Java. So I've kind of seen a lot of patterns out there, and in this web technology world, there are a finite number of them that you can kind of experience as you go about your career. I've obviously worked on monoliths and microservices. In fact, LinkedIn, during my tenure, went from a monolith to a heavily microserviced kind of stack. So it's a small note. They all are right answers. Whatever helps you move fast, because very often that's like really important. If you look at companies, decisions made by companies like Facebook versus Google, you'll notice Facebook was, is this like very complex application, and they need to move fast in like so many directions. And I think things like GraphQL emerged out of that necessity. And versus Google, where traditionally their business is more solid, and like someone put it, they're this text box. I forget who said this, but they said Google is this text box with this massive software infrastructure behind it. That's and that's kind of true, and the business is pretty solid, so they can move slowly and more strategically, I guess. So. Anyways, why are APIs important? So there's obviously a lot of things happening in the world. API first is kind of what the world is moving to, where everyone's building APIs before everything else. There was this term mobile first, where they talked about moving to building mobile apps before the website. And honestly, even in that world, you need to build an API before you have a mobile app. So there's API only. So several startups are now just an API. With they're like, hey, pay us for using this API to get leads, or to sanitize this, or do this machine learning thing, or like a friend of mine launched an API for a startup that will deliver medicines. So it's really interesting. All kinds of stuff. Integrations are really important. A lot of SaaS startups need to talk to each other, and that's how you kind of keep your users, make your product more sticky. Full stack developers. This is another way where you have people that are working on every part of your stack, and you really want them to be productive. And having to like context switch for every little thing is hard. So if you have an API that's very set in stone, and the person is working on the UI, and then he needs an extra field or some data that's not available, he has to like context switch back out of his UI world into this backend world, into a different language, and then add that data, change the API to like add that to it, and then switch back. And this is it's not productive. And relational DBs, honestly, I think the world went through this whole phase where they talked about NoSQL and all of that. I think they all have their place, but there's with Postgres being, and also it kind of went through this phase where MySQL was very dominant, and then it kind of stuff happened, and people tried to explore MariaDB, and I've got the sense now that a lot of the world is standardizing on Postgres. And so that's kind of like a move that is going to be tied into my talk too. But we'll come back to that. What is web development today? Web development today is you end up making these APIs, and everyone knows these. You make essentially, this is not, obviously everyone has a lot of complexity in their app, and there is a lot of value everyone's creating. But essentially what we're doing is we're building these CRUD APIs. And we're doing this, I'd say 80% of most web development work is building like a create, delete, update kind of flow for every little thing, piece of data that you're working with. That could be a product for like an e-commerce thing, or users, or whatever. And that's no fun to do. Honestly, you want to work on the meatier parts of the app. You want to build something really cool, and you don't just want to add this additional CRUD API that your product manager added a ticket for. And so if you look at APIs today, for example, your startup, you'd have, OK, get all products that belong to 5 users. You have that. And one of us has to make a decision here. They're like, OK, let's add products after users with the ID there, or do we create a different API for products and just like let them pass in the ID as a param? There's no standardization. It's all these decisions around every little API. Or you kind of come together as a company and you decide, oh, we'll only pass it as params. And it's this like thing that you have to figure out every single time. And then when you want to change the data that it's returning, that endpoint, for example, you don't want the whole product, but you want just like part of it, just the title, or maybe there's something missing in it, then you have to figure out a way to munge that in. You might say, oh, let's create an API called mini product, and that only returns like 3 fields instead of 2. And then the product manager opens a ticket and says, oh, mini product's great, but it's missing the photo, so let's go add that in. And honestly, it slows everyone down. So what's the problem here? Well, obviously, too many decisions. That's not good. You want to move faster. You don't want to be like blocked on every little thing and having to like call a meeting and decide every little thing. There's no consistency, so you can have parts of your app that's using one schematic because the developer previously just made that call, and then another API doesn't accept this filter because the new API developer didn't really go back and figure out what the company was, what pattern they were following. And this kind of happens over and over again for every APIs you add when your company's APIs like balloon, and there are a bunch of them. So there's also what they call overfetching. This is another big problem where every time you request data, like a product, you have to go back to a database all the way, and you have to fetch everything you want to return. And this could be a lot of information. And sometimes that's not good either, because sometimes it's not just the product, but it's also the associated relationship. So you're taxing your database when you honestly just want to render a little card with just the title, and or you go build this mini API, right? So my whole talk is centered around the fact that we need to move fast. So it's not, there's a lot of this move fast, break things kind of concept coming out of Silicon Valley. And honestly, if when you're a startup, you're trying to figure something out. Usually, you're a startup when the term startup applies to any company that's still trying to figure out their business model. And that just needs you to pivot and change and throw code away and change stuff you're doing like every week. And like having things set in stone, trying to build these like elegant APIs that are going to work forever just doesn't like fit that bill. So while you might want to look up to big companies and see how they do things, that doesn't always apply to a small company, because you are in this everything is changing all the time kind of world. And honestly, like every successful startup that I've known has always ended up very far from where they started in every sort of way, including the business, the plan, the initial idea, everything. I mean, you call it pivoting, you can call it, iterating, you can call it whatever you like. But it's, the plan you start off with is like it basically falls apart pretty quick when it makes contact with the market. So it's always the case. So. All right, so how does GraphQL help in this case? So GraphQL is essentially a querying language. This is it's a language that basically everyone has kind of standardized on. It was something invented at Facebook. They decided that we want an ability to query our data backends and we want to give this querying power to the web developers or the client developers. Traditionally, this power has always been with like what they call the backend developers, and they're the gatekeepers. They're like, hey, you know what? I'm going to call this field this thing, or I'm not going to add this thing. It's too complicated, or whatever, right? And the front end's always blocked on that. But GraphQL basically takes this kind of data munging, data querying capabilities and pulls it up all the way to the client developers. So if you're building an app, you're building a web app, whatever it may be, you can now ask for the information you need. So you'd be like, hey, just give me, like this query, for example. This is basically this. In this case, you're saying, give me a user whose ID is 5. Give me all the products attached to him. Give me only his ID and name. I know that backend returns image, but I don't want to call it image. I want to call it photo. I also want customers. And I want all the customers related to this product, and I want their names and emails. And now, if the product manager decides to add one more field in here, it's him and the front-end developer that can make that change really quickly. And you don't have to go and change everything in the whole chain of command per se. So I'll go into some examples of that. So what are the bad parts of GraphQL? So GraphQL is a post-only query. So what you're basically doing is you're posting this query back to a GraphQL service that is then fetching that information and for you. And people, the things I hear out there about that are kind of reasons for not adopting GraphQL are things like because it's post, it's not cacheable. But very often, I've not seen anyone caching APIs regardless of what it is, right? I mean, and if it is, if you do really need to cache it, the browsers are sophisticated enough now to allow you using service workers and stuff to cache whatever you want. Caching is not something based on your HTTP type anymore. The browsers have given that control over to the JavaScript developers a long time ago. So the GraphQL is also only for fetching data. Well, there is an ability to change data. It's called mutations. But that's not really, there isn't enough work there. It is, I would say, still lacking in many ways. It's just the ability of saying, OK, just create this thing for me, and that's about it. What if you have a nested object and stuff? It's not defined as well. But fetching is what we do a lot more than writing. And also sometimes writing needs all these complex business rules, so it's fine to keep it on your existing REST endpoint per se, especially if you're kind of moving into GraphQL, which most people will be and not writing something from scratch. The new frameworks to learn, honestly, I didn't get into GraphQL early. I got into it pretty recently. And one of the reasons I never got into it before, or I kind of read about it, I saw it on Hacker News, and I talked to people about it. But what kind of put me off it is all this documentation around GraphQL frameworks. I looked into it. There was something, I don't even remember all the names there. I think there was back then it was Apollo and a few others. But it's just there was so much documentation and so much JavaScript code I had to write, and it was just this new thing I had to invent. And I was hoping for something that, where I didn't have to write any code or very little code, and it just kind of worked. It's an API. Another thing people say, it's just a gateway. It's something that you query it, and then it goes down, and it fetches from your existing endpoints. And that's not true. GraphQL can itself talk to your data sources. And obviously, write more code. That was the reason why I did not adopt it for a while. But I have my own startup. It's based on Rails. It's called Move North, and it's a Rails app. So it works well, but my UI is now recently been migrated to Vue, and that's like React. And I'm running into these same issues where I need to fetch data. And that's kind of around where I started exploring GraphQL. I was like, OK, I have this database, Postgres, has all this data, has all these relationships. Can I just query it? I mean, does Postgres have a GraphQL endpoint? I mean, why not, right? I mean, I looked. Obviously, there wasn't one. I noticed a lot of the other ones needed me to write a bunch of code and kind of reinvent my controllers. And I didn't want to do that either. So let's segue into the database. A lot of people talk about microservices. Essentially, what is a microservice? Yeah, it's ability to kind of own your own code and deploy it separately from the rest of the code and all of that. But there are many reasons for building microservices. One of them is scaling your own data source. And essentially, to me, from what I've seen out there, is a microservice essentially a wrapper around some kind of data. Usually, it's one data store of some sort. Maybe you have a high write volume. You're like Facebook, and you want to write all these bunch of likes. And a relational database is not going to stand. You want something more distributed, like Bigtable or whatever, right? Or you have something more simple, ACID transactions. You want to guarantee the payment data is saved, and you want to use Postgres. So a lot of people don't realize that Postgres can do everything. Postgres is a microservice. You can deploy multiple versions of it and take care of every need you have. It supports JSON. You can actually make it a key value store. You don't need Mongo. You can have a column, and then just throw JSON into it. It'll compress it for you. It'll let you query directly deep into the JSON. It's very efficient, even stores binary JSON. It has full text search capabilities. You can create a term vector column, and it will basically index everything, and you don't need Elasticsearch or Lucene or anything. Its searching is just as good, even better. You can build a GraphDB on Postgres using something called with recursive queries. There are a bunch out there, a lot of people using it. Time series databases, window functions, PostGIS for location stuff. You can add your own columns. Like Bloom filters are great if you want to do joins of certain types where you have duplicates and you want to count deterministically certain things. And so you can add that to it. So I mean, it's very extensible. Plus, it has a lot of stuff just out of the box. So that got me thinking about what if I have a service that just exposes Postgres as a GraphQL endpoint. And that got me to build something called Supergraph. So Supergraph is something I have recently open sourced. It's written in Golang, so it's quite it's designed to be performant. It essentially is a compiler. What it does is it takes GraphQL and it compiles it into a single efficient SQL query. So that GraphQL you saw before, it would basically compile it and query a database and get you the data back. And the database in this case is Postgres. It also exposes all these features of Postgres, like full text search and some of these querying capabilities. It does aggregation, so you can say, hey, count this up for me. And it does all of this without you having to write any code. So essentially, it is a GraphQL endpoint. And my aim here is to actually build something where I can stop writing code and start building apps with the most minimum amount of code for specialized things. Like if I need to send out mails, I need to do some machine learning thing, then I can write code for that and not CRUD APIs. I guess I've written enough CRUD APIs in my life to last me a lifetime. So I'm trying to find a way out. So just back me there. So let me jump into a quick demo. So the way GraphQL Supergraph works is it is something you run alongside your existing app. In my case, it's a Rails app. So and most apps use cookies for authentication, or they use something called JWT tokens. So Supergraph can understand, decode both of those. They can decode Rails cookies, they can decode JWT tokens, and they can extract the current member from there. So that way, you don't have to add any authentication, it just works. So, and how does it know about your database? Well, I mean, you're connecting it to a Postgres database. So it queries it. It says, give me a list of your tables. Tell me about all the columns in the tables. Tell me about how they're related to each other. And then it learns this entire graph of relationships. So essentially, you just deploy it, and now you can query your database. So in this case here, I'm going to quickly log into a Rails app that I have. It's like a demo app right there. Now I can query it. So I've basically issued a me query. I'm saying, OK, just tell me the user me. So Supergraph is config driven. So you have to configure certain things in there. So there is a config in there that's saying me maps to the users table. And it's where user ID is equal to the current user's ID. So it's returning this information for me. I think this is kind of a little too small. All right, so if I go back here, and this is the query that we were trying. So if I take that query, and I decide to try that one, there. So it's now returned the users, the products for the users, and if you scroll down, it even returned the customers. So these are all the products that user had. So you can do things like full text search. It has a whole website where you can read up on it, and it's kind of well documented. Let me try the full text search. This is something normally you deploy a different service for, and have to complicate your stack. But this uses Supergraph just uses Postgres, the built-in search capabilities, and here it will search for ale. So it would search for all the products that have the word ale in it, and it will return a search headline too. So it will actually kind of mark. I guess there's demos never work right, so. But it's technically returned the correct names, So essentially, what I'm trying to do here is give you a GraphQL API without writing any code. And if you've noticed that most of these things also have relationships built in, like the customers, the users, and it kind of resolves all of that. I mean, yes, you don't have to use Supergraph to use GraphQL. GraphQL itself gives lets you move faster. You can obviously pick your poison. There are many frameworks out there. I haven't sat and evaluated them all, but there are a lot of mature ones that I used extensively. So yeah, well, use GraphQL. Thank you. Sure.
So you covered authentication. How do you handle authorization?
So in the back end, you put in these GraphQL filters. So essentially, in the config file, you add a filter that's exactly like a filter that we support, kind of like a where clause. And it just inserts that where clause into the query. So you say for the users table, I want a where clause that only lists the user where the ID is the current user's ID. In which case, it would, let me see. It would insert that where clause. So if you look at Postgres, a lot of people don't realize it, but Postgres has its own row-level security. So you can actually have filters or where clauses that you can append on every post, update, select, anything you want. So we're essentially doing that. You construct a where clause, and this is what you would write in your code too. So if you were kind of doing this yourself, you'd be like, hey, where user ID is equal to the current user.id. Right? So essentially, we're putting that as a filter in the config file. So every time anyone queries for anything related to user, that filter is inserted into the SQL. So this is I can show you the SQL it kind of generates in the backend. So yeah, sorry.
Oh, I get it.
Yeah. I'm not going to read that anyways. So. I think essentially I started off. One of the reasons I kind of like GraphQL is I think it's a better SQL because SQL I think traditionally is it's just an opinion, but I think it's a bad language. I mean, it's very powerful, but if you really look at the SQL specs, which have not all been implemented by every database there, it's like that thing. And if you look at SQL, I mean, I have a little bit of experience in software, and I cannot figure it out half the time. It takes a lot of effort. I mean, it's not an easy to read language, and I think the tooling around it is just not there yet, and even after so many years. And most engineers, surprisingly, don't know SQL. I barely know it. So, and I'm like writing some compilers for it. So, and ORMs and stuff have traditionally kind of limited how much of the SQL subset we use. And it's a way of us not having to learn SQL. But GraphQL kind of like allows you to expand that and use more complex queries, but kind of bringing SQL out from there into the browser. So what if you could write SQL in the browser and just query your thing in a safe way? That would be the ideal thing. But SQL is not a great language, and you don't want to, like, GraphQL is much more familiar to people who live in the JSON world. It's still got the curlies and Sure.
So question about, this is sort of more of a generic GraphQL question, but so say, have you seen GraphQL be used as the generic language between microservices when, say, splitting up a monolith?
I've spoken to a few people who've started to do it. So I've, I mean, sometimes engineers are, I think GraphQL still has this like, what's the best word for it? It has this like, people perceive it as something that just web devs, it's in the browser, it's not performant enough between services, and they want to use they want to go all the way and use like protobufs or something between services. And sometimes, like very often, you don't need that level of, and if you have something performant that's parsing, I mean, you're using JSON, and a lot of languages are not very performant at parsing JSON, and you still talk JSON between services. So I mean, if you have something that's, good, it caches the generated JSON because your queries are often the same. It needs to template them well. Like this one, like Supergraph does cache queries and it then templates them. So if you have some specific information gets inserted later on, but so it's not compiling every time. So things like that really, I think will encourage people to use it between tiers. But I know people are. I mean, even on Twitter, I've seen people who've claimed, oh, we use it everywhere. We love it. So. And there's also this whole trend where microservices are not just internal consumption. Now people are moving to Kubernetes and stuff where there's a gateway that just exposes that same microservice out. And essentially, you're still passing the same JWT token all the way through internally to, you're not, it's all encrypted. You don't want someone within your infrastructure to be able to query your endpoints without a really signed token. So you really, it's like everything is a public-facing endpoint in some sense. So yes. Yes.
What type of use cases do you see for Supergraph? I mean, one thing I can think about is maybe some sort of an admin interface on top of the database. So I don't know if I'd use this as for like my primary application for like to expose it to users, but as an admin interface, this actually seems like it could work fairly well. Is there anything else that, or maybe I'm wrong?
Yeah, no, it's fine. I think, admin interfaces, honestly, I think someone needs to like build like a really cool admin interface everyone can use. And I love Rails for that because it saves me, I just like add gem administrate or whatever, and I get an admin interface, and I don't write a line of code there. And but essentially, like what I've seen here is that it's like ourselves move north. We use it in parallel with our Rails app, where all the writes go to our Rails app because it does a bunch of business logic and all of that, and all the reads that are happening from our main website, which is quite heavily trafficked now, is it goes directly through it hits our GraphQL Supergraph endpoint, which then has query caching and all of that. It has a single performant SQL query. It's Go code. It's not it's multi-threaded, all of that, and it goes straight to a Postgres database. Low allocation, so it's very, very fast compared to if that same path was through a Rails app. And essentially it's more performant because then I am not like sitting and making sure my active record query is just the right thing, and I'm not doing an n+1 because this is not n+1. All the queries are just a single query. So in terms of security, I mean, essentially in my Yes, it's authenticating the token or the Rails cookie. So yes, if you're not an authenticated user, you're just going to get a 401 back. And if you are, then it's essentially doing the same thing your Rails apps does. Because if you have a product and you want to limit the product only to people within that SaaS tenant, then you want to say something like, whenever anyone requests for a product, you want to say where account ID is equal to the user.account ID. And you want to kind of insert that where clause into every single list, right? And that is defined in a config. So essentially, if you go down to, sorry, I'll just quickly, easier to set up. So if you go down here, you see that's right there. Is basically, it says user stable. Just add this filter to every single query. It says ID is equal to the user ID, which is the current user ID. Or for the product stable, insert a filter where price is greater than 0 and less than 8 for every single query to the product stable. Or if you want to create like a synthetic table, you can just do something like me. You can say, OK, create a table. If anyone requests from me, make sure that the table is users, but then use this filter. So it's essentially, I'm not saying there are corner cases where it might not fit your thing, but most cases I've seen it works pretty well. You can define variables. You can have your own. You can say, OK, every time you ask for account ID can be this like select. So it would kind of work in a SaaS environment where it would join in the accounts table for the user and then have the accounts ID, and then you can then say, OK, it's not the user ID that I want to return this data based on, but the account ID for that user. So that's more a SaaS kind of multi-tenanted setup. Yes.
Yeah. So I mean that was the question I was going to ask until
Sure.
you started talking about this, because at least with the well-formed REST API, your requests are very specific, and you can really tailor down what you're returning to your users. Whereas I see this as until you started talking about being able to define all this, is really open-ended, right?
Yeah.
And I mean the developers who are interacting with your API could really get into a lot of trouble, or could really start pulling a lot of data that they don't need,
Sure.
or don't want, or you wouldn't want them to have. But
so yes, this limits it, but I've seen even in the world where you're writing all the code, there is more of a chance of you making mistakes, and because you're kind of the developer making mistakes because they're building the same thing again and again for so many endpoints is not a central kind of way to look at things. So it's sometimes you might have an endpoint where you forget to put in this where clause that you should. So you're technically getting all the likes for the whole company, where you should only get the likes for the people who are part of that group within a company. I mean.
Yeah, well, I hope you do your testing.
It's often, again, I think this is useful in the move fast, break things kind of world.
Well,
and it's, I wouldn't say that it's the best if your business is solid and you just want to but if you don't want to if you're constantly changing, you want to move fast, I would appreciate something like this for the part of the code that's boring, and the fun stuff that I can then build out the more interesting parts of my application. So
this would be a use case for this could be entitlements. So there's a bunch of users firm that's entitled to different parts of
yes, I mean essentially, authorization, authentications.
So another thing, what about the writing part? We talked about mutations.
Yeah, so mutations, Supergraph doesn't support mutations right now. That's why it runs in parallel with your Rails app, or it supports a lot of different apps, anyone who uses Postgres at this point. And essentially, I'll support other data stores because it's a compiler, so it can, right now it writes very Postgres-specific SQL. For performance reasons, it could write, other key value store kind of SQL or whatever, data store or something. So, sorry, yeah.
That was my question.
Okay.
I might have missed that.
Sure.
So, is the GraphQL schema driven by the database schema? Which comes first, I guess?
So the database schema. The database schema drives everything here. A lot of the other GraphQL frameworks that I've seen require you to define a schema, and that's also part of the SQL spec. I didn't get into it because initially the way I looked at it is that I have my migrations, I have the database schema, and there's a lot of information in there. I would rather just define a lot more of my rules in there.
Well, you're starting with an existing database. That's why
yeah, but traditionally, I think GraphQL, the way it works, it starts from a schema. Unfortunately, I've kind of skipped it here. And a lot of people define that, and then there's auto generators too. So there are frameworks out there that will take the schema and generate code for you. That's another way to go. You don't have to write it. That's and it'll generate even the client code for you. So it's just that I'm doing that on the fly per se. So sure.
Another more generic GraphQL.
Absolutely.
But so like in prod, like GraphQL in production, like I think a lot of people understand SQL performance, right? You know, oh, this is why it's broken.
Sure.
I mean, I've heard that there are some frameworks to sort of limit some of the N+1 potential that GraphQL sort of introduces. Just maybe some comments on
sure.
GraphQL and prod as far as performance, and then like audit, like troubleshooting.
Well, I think you have to have logs. You have to have some mechanism to know your slow queries. I have seen slow queries the Rails world. There's a gem you can throw a bullet or something which can just tell you where you're not fetching correctly. But I've spoken to developers even until recently who'd be like, I've never used a join in my life. Why do I need it? I'm just going to use a key value store. I'm like, okay, I'm sure you did, or your app is just not getting enough traffic, so you're fine. And you could build $1 million business and not care about your N+1 queries. So, but yeah, there is. I'm trying to solve that in one place. So as that compiler code evolves, it would just like deal with it, and doesn't have to like every endpoint you build, you don't have to be like you don't have to keep these things in mind that am I. But it's no different. A lot of GraphQL now is essentially not directly talking to a database. It's still talking to existing REST endpoints. And in which case, whatever the REST endpoint does. In fact, there's another feature here that I didn't kind of get into, which is remote joins. So like in your database, you might have a table called customers. And then you have a field in there called Stripe ID. And now you want to get you want to call Stripe, and you want to get all their payments of that customer and join it with this single database result. And this one can do that. So Supergraph can handle that too. So in this case, it is, let me try it. They say about live demos, right? Yeah, well, yeah. Well, unfortunate there. But yeah, maybe OK, I don't know why that didn't work. But essentially, it can like make a remote request in a very efficient way. It will like join it with, and it can pass whatever cookies headers you want. So.
Does Stripe have the GraphQL API?
Oh, it's REST. So right now, it doesn't support sending GraphQL. It talks to remote REST endpoints. So it will put the, it's not a post, it's a get. So it tries to insert whatever ID it's in the database into wherever you need in the URL. Like in this case, it's inserted the ID at the end.
So this will be like an N+1 call because
it would be an N+1 call because it's remote. But it still does it in parallel because Go supports these really cool concurrency features. So essentially, this could be extended to support like batch APIs and stuff, but yeah. Sure.
So how does versioning work? Is it based on when your schema changes?
How does it? Yeah, I mean, when your schema changes, you have to redeploy. So essentially restart. So every time it restarts, it reads the database and then learns the whole structure of it. So I'm trying to like make it read the migration files. So it can then, kind of that could be the source of truth. I was hoping to build my own migrations kind of framework because I wanted to define things like this field is an email address directly in there, and I want that to be surfaced because GraphQL has really interesting features. I didn't get into all the details of GraphQL because people can Google that. But it has the ability to introspect. So in this IDE, which I didn't build, this is called GraphQL Playground. I just kind of like took it. It lets you actually get a schema, and as you're typing this in, it will auto-complete it and stuff by querying the backend for like an API documentation per se. So you can surface exactly what you want to about every field. GraphQL also has this thing called subscriptions. So you can actually subscribe and say, oh, I want every change to this field, I want to know about it. And then it would, GraphQL would basically use WebSockets, and it would just update your application on every change to that query. So, and now there's something called live queries, and they're really extending the protocol, the protocol. So it's a lot of interesting things coming out. So your app, essentially, if you want to make an app that's more dynamic, changing all the time, GraphQL is another great option for it. I also support tracing here, so if this didn't work here, but let me try it. So it'll tell you like exactly how many seconds each part of the request took and stuff. So. All right, so if there are no more questions.
Thank you, Vikram.
Thank you.